In this video, we discuss a new topic, that is Lami's theorem, which is based on the concept of concurrent forces. Lami's theorem, which is based on the concept of concurrent forces. So suppose there are three concurrent forces. There are three concurrent forces. F1, F2 and F3. There are three concurrent forces F1, F2 and F3. F1 vector, F2 vector and F3 vector. These are three concurrent forces because all these three forces act at a single point, and let the angle between force F2 and F3 be alpha, angle between force F3 and F1 is beta, and the angle between force F1 and F2 is gamma. We have taken three concurrent forces F1, F2 and F3. The angle between force F1 and F3 is beta, between F2, F3 is alpha, and between F1 and F2 is gamma. And these are three concurrent forces. So let us draw the diagram in a triangle where we represent these forces in a triangle. So this is force F1 and this is force F2. So let this direction shows the force F2 and the direction of force F3. This is the direction of force F3, and the direction of these forces are F1, F2 and F3. Now the angle between force F1 and F2, the exterior angle between the force F1 and F2, between force F1 and F2 is gamma. This angle is gamma. The external angle between the force F2 and F3, between the force F2 and F3 is alpha, and the force between F3 and F1, which is beta. This is the force beta. These are this is the angle beta, and these are the external angles alpha, beta, and gamma. They are the external angles. So what would be their internal angles? If this angle is gamma, then this angle be pi minus gamma. And if this angle is alpha, then internal angle will be pi minus alpha, and this angle becomes pi minus beta. Because this is a straight line, and on a straight line there is total angle pi, we have to calculate this angle, so it becomes pi minus beta. Now we use sine rule from mathematics. The sine rule says that if there is a triangle ABC If there is a triangle ABC and the angle between side AB and AC be alpha, angle between AB and BC is beta, angle between side AC and BC is gamma. So it is represented by the sides of the triangles represented in terms of angle, which is called sine law. AB, side AB, and the angle opposite, just opposite to the side AB, which is gamma. So AB upon sine gamma. For side BC, the angle opposite to the side BC is alpha. So BC upon sine alpha is equals to the side AC, and opposite angle of side AC is beta and sine of angle beta. So they are the constant ratio. AB upon sine gamma equals to BC upon sine alpha equals to AC upon sine beta. This is a constant ratio. So in this triangle, the angles, and name the triangles as A, B and C. The vertices of the triangle A, B, C. So we use sine rule, and these three forces are the concurrent forces because their resultant is zero or they act at the same point. These three forces act at the same point. So we use the sine rule. To apply the law of sine to triangle ABC. Apply the law of sine for triangle ABC. So AB, side AB and opposite angle of side AB is pi minus alpha. So sine of pi minus alpha. AB upon sine pi minus alpha equals to another side BC, and the angle opposite to the side BC, interior angle opposite to the side BC is pi minus beta. So sine of pi minus beta, sine of pi minus beta equals to side AC, and opposite angle of side AC is pi minus gamma. So sine of pi minus gamma. This is the sine rule which we apply for triangle ABC, and there are three forces and the angle between consecutive two forces are given. So the side AB is represented by force F1. So we write F1 upon sine pi minus alpha. Side AB is represented by force F1. So F1 upon sine pi minus alpha. Side BC is represented by force F2. Side BC is represented by force F2. So F2 upon sine pi minus beta, and the side AC is represented by force F3. So F3 upon sine pi minus gamma. And we know sine pi minus alpha is equals to sine alpha. So F1 upon sine alpha equals to F2 upon sine beta is equals to F3 upon sine gamma. So this is called Lami's theorem, which we use in solving the problem. Suppose the three angles are given and two forces are given, and there is one unknown force which we have to calculate. then we use the Lami's theorem. So the statement of Lami's theorem, if three forces acting on a particle, if three forces acting on a particle if three forces acting on a particle keep in equilibrium, if three forces which are acting on a particle keep in equilibrium, then each force is proportional to, then each force is proportional then each force is proportional to the sine of the angle between sine of the angle between other two forces, sine of the angle between other two forces. This is a statement of Lami's theorem. If there are three forces and which are acting on a particle and keep in equilibrium, then each force is proportional to the sine of the angle between other two forces. Now we discuss few numericals based on equilibrium of forces and also on Lami's theorem. The first question is, a mass of 6 kg is suspended by a rope. A mass of 6 kg is suspended by a rope. A mass of 6 kg is suspended by a rope of length 2 meter from a ceiling. Of length 2 meter from a ceiling. A mass of 6 kg is suspended by rope of length 2 meter from a ceiling, a force of 50 Newton in the horizontal direction. A force of 50 Newton in the horizontal direction. A force of 50 Newton in the horizontal direction is applied. A force of 50 Newton in the horizontal direction is applied at the midpoint of the rope. At the midpoint of the rope. What is the angle the rope makes with the vertical? What is the angle? What is the angle the rope makes with the vertical? What is the angle the rope makes with the vertical in equilibrium? In equilibrium. And take the value of G, 10 meter per second square. So we are given a mass of 6 kg is suspended by a rope of length 2 meter from a ceiling and a force of 50 Newton in the horizontal direction is applied. A force of 50 Newton in the horizontal direction is applied at the midpoint. At the midpoint of the rope, force is applied in a horizontal direction at the midpoint of the rope. So what is the angle the rope makes with the vertical direction? So we have given the ceiling and a rope is inclined because a force of 50 Newton acts in the horizontal direction in the middle. Rope is inclined because a force of 50 Newton acts in a horizontal direction and a mass of 6 kg is suspended. Here a mass of 6 kg is suspended. So its weight will be 6 kg weight. 6 kg weight. So, and the length of the string is 1 meter. The length of the string is 1 meter. This is 1 meter length. And this length is also 1 meter. Because the rope of length is 2 meter. And the tension acting in the rope. Suppose since a string rope is suspended from the ceiling, so the tension act is T1. Let in this portion the tension act is T1 and in this portion the tension produced due to the weight which is equals to T2. And let the rope of length 1 meter is making an angle of theta with the vertical. It is making an angle of theta with the vertical. And if this angle is theta, then alternate angle, this will also become theta. Now, there must be two components of T1. There must be two components of T1. Its one component lies in horizontal direction and which is T1 sine theta. And its other component lies in vertical direction which is T1 cos theta. So T1 sine theta and 50 Newton, they act at the same point and their direction is opposite. Similarly, the force T2, T1 cos theta and 6 kg weight, they act in opposite direction. So we resolve these forces. So T1 sine theta is written as 50 Newton. T1 sine theta is written as T1 sine theta is equals to 50 Newton. Since these two forces are opposite in direction, so we can equate these two forces. So T1 sine theta is equals to 50 Newton. T1 sine theta is equals to 50. This is the first number equation. T1 sine theta equals to 50 and T1 cos theta, which acts in vertical direction. This is equals to 6 kg weight. So T1 cos theta is equals to 6 kg weight. And this is the mass. 6 kg is mass. So we'll have to multiply it by acceleration due to gravity. So we get 60. So 50 by 60. Now divide first by second. Divide first by second. So we get T1 sine theta upon T1 cos theta equals to 50 upon 60. 1 0 gets cancelled, T1 cancelled, and we get the value of tan theta equals to 5 by 6. And the value of tan theta equals to 5 by 6. This is equals to tan of 39 degree and 8 minutes. So the value of theta becomes 39 degree and 8 minutes. So this is the angle which, or 39.8, we can write is 39.8 degree. So 39.8 degree. This is the angle which the string, which the rope makes with the vertical. The rope is making an angle of 39.8 degree with the vertical. Now the next question is based on Lami's theorem. The next question, a ball of mass 1 kg hangs in equilibrium. A ball of mass 1 kg. A ball of mass 1 kg hangs. A ball of mass 1 kg hangs in equilibrium from two strings. Hangs in equilibrium from two strings. Mass of 1 kg hangs in equilibrium from two strings OA and OB. OA and OB. So what are the tension in strings OA and OB? What are the tension? What are the tension in strings OA and OB? Tension is a force, so we have to calculate the force acting in a string is called tension force. Take the value of G equals to 10 meter per second square. The value of G, take G equals to 10 meter per second square. And we have to calculate the tension in the string. And the angle which we have given is 120 degree, 150 degree, and there are three forces A ball of mass 1 kg hangs in equilibrium from two strings. And the strings are OA and OB. OA and OB. These are two strings and a mass of 1 kg and the angle is 150 degree, 90 degree and 120 degree and the ball of mass 1 kg. This is 1 kg mass. Is suspended. Mass of 1 kg is suspended. So let us take the three forces. Suppose the tension in the string of part OA is P1, tension in the string of part OB is T2, and tension in the string of part this is T3. And the value of T3 is already given 1 kg. So if this is angle 90 degree, then this angle is also, these two angles are also given, and these angles are respectively 30 degree and 60 degree. We have given these two angles also 30 degree and 60 degree. So we use the Lami's theorem. So from Lami's theorem, P1 upon P1 is the tension and the angle between other two forces, means the angle between T3 and T2, which is 150 degree. So T1 upon sine 150 degree is equals to T2 upon, T2 is the force on the string OB, and the angle between other two forces T1 and T3 is 120 degree. So T2 upon sine 120 degree, and T3, which is equals to 1 kg, and 1 kg is the mass and G is the given 10. So force will be 1 into 10, which is 10 upon angle between other two forces, means T1 and T2, 90 degree. So sine of 90 degree. So we use the Lami's theorem for three forces. T1 upon sine 150 equals to T2 upon sine 120 equals to 10 upon sine 90 degree. And sine 150 degree is also equals to sine 30 degree. Sine 120 is equals to sine 60 degree, and 10 upon sine 90 degree is equals to 1. So equate first and last. So T1 upon sine 30 1 by 2 is equals to 1, and the value of T1 by cross multiplication, it gives 1 by 2. So T1 equals to 0.5 Newton. This is the force T1, which is equals to 0.5 Newton. Now from last to T2 upon sine 60, the value of sine 60 is root 3 by 2 equals to 10, and T2 equals to 10 into root 3 by 2. So we get T2 equals to 5 root 3 Newton. So these are the two forces acts on a string OA and OB. T1 force is 0.5 Newton and force T2 is 5 root 3 Newton.